Hello, my dear students. In first lecture, we learn about machine tools, turning process and lathe. Now second lecture, we have to learn about lathe components and feed mechanism. In lathe components, we see about the part carriage. In carriage, controls and support the cutting tool. By the help of this tool moves away or towards the headstock. It has 5 major parts: saddle, cross slide, compound rest, tool post, which are on the saddle. Then apron is below these components. Apron, here see in this picture below. In apron it is fastened to the saddle and contains the feeding mechanism. The apron hand wheel can be turned by hand to move the carriage along the bed on the lathe. The automatic feed lever is used to engage power feeds to carriage and the cross slides. The next point is feed mechanism. In feed mechanism, the movement of the tool relative to the work is termed as feed. A lathe tool may have 3 types of feed, that is longitudinal feed, cross feed and angular feed. When the tool moves parallel to the work, that is towards or away from the headstock, then that is known as longitudinal feed. When the tool moves perpendicular to the work, that is towards or away from the operator, then it is known as cross feed. When the tool moves at an angle to the work, it is obtained by swirling the compound slide. Cross and longitudinal feed are both hand and power operated, but angular feed is only hand operated. The feed mechanism has following units. Through the motion is transmitted from the headstock spindle to the carriage. End of the bed bearing, feed gearbox, feed rod and lead screw, apron mechanism. Now come to the next point is cutting speed. It is the speed at which the metal is moved by the tool from the work. It is circumferential speed at work against the cutting tool and expressed in meters per minute. The figure shows here the feed is given, then D is the diameter of the workpiece, then T is the depth of cut, D1 is the again reducing diameter with the help of single point cutting tool. Then cutting speed equal to pi dn upon 1000, unit is meter per minute. Then depth of cut. Depth of cut is the perpendicular distance measured between machine surface and unmachined surface of the work. If the depth of cut may be taken from 2 to 5 mm for roughing operation and from 0.5 to 1 mm for finishing operation. Again, this figure shows this is the diameter before the work of the job. After operation, D1 is the second diameter, that is machine surface. Then depth of cut can be calculated by D minus D1 upon 2. Then machining time. The machining time in the lathe of the work can be calculated for a particular operation. Here the machining time is given by T equal to length upon feed into speed, where these units are given for feed mm per revolution, length is in mm, speed is in rpm, then time, machining time in minutes. This figure shows the parameters. So next is, I can help you with the help of the example that is given on the green board. Name that is written in normal writing, that is Professor Dr. G.C. Jadhav. It is normal writing. Then if I increase the speed, what happens? You see Professor Dr. G.C. It is not readable. Then again I increase the force of the chalk. Then again it is not readable to you. It is just like a doctor writes on the medical prescription for the patient. Only the pharmacist can read the VC writing of the doctors. Such that these are the importance parameters, their speed, feed and depth of cut for rough finishing to finished surface. So we have taken the account of these parameters. Always use the optimum parameters for getting the better finish. Thanks and take precaution.